One.
So now we're going to practice some quantitative energy analysis. If you notice, the word quantitative stems from the word quantity, right? So now we're calculating the amount of energy in the system. If you recall, the first the first quiz just covered the energy bar charts. So we were just looking at the proportions of energy in each part of the system. Now we're getting into the actual numbers, actually calculating energy. So if you study this, you will do fine. Okay, please make sure right now, maybe pause the video and double check that you have slide 17, 18, and 19 copied into your notebook. Slide 19, you're going to need to recopy because there is an error in it before and I fixed it. So you're going to have to repaste that one. So pause the video, make sure that you have these three copied in there. Okay, so now that you have the slide, you should be looking at slide 17. So you're given all of these equations here. This is essentially what your quiz is going to look like. And if you practice and you understand it, you ask questions, email me if you need, you'll do fine. One thing I do want to note is tomorrow, which is Thursday, December 12th, I'm going to be hosting a work time in my classroom. If you wanted to come for extra help, if you need to finish a lab, if you need to make up a quiz, whatever you need to do, if you want to come in, I will have my classroom open during both lunches. So you can come in during that. Okay, so your quiz on this is going to be on Friday. So make sure that you follow along closely. So here you're given the total energy before is equal to gravitational energy plus kinetic energy plus the total energy after. What this is saying here is essentially that the conservation of energy, right? Whatever energy we have in each part, if we add it all up, should equal to whatever energy we started with. The next equation is gravitational energy, which we've talked about plenty times. We have mass times gravity times height. Then I give you the kinetic energy equation, which is half of the mass, 1/2 mv squared, right? Velocity squared. The third equation, or the fourth equation here, is for elastic energy. This is the equation that we just found in the elastic energy lab. So you have elastic energy is equal to kd squared. The K here stands for spring constant. Remember that every single spring in the whole entire world has its own unique spring constant, and this tells us how stretchy the spring is. So for example, if you had a really stretchy rubber band, you're going to have a spring constant that is small. Versus if you have a really stiff rubber band, one that takes a lot of energy to stretch, this value is going to be really big. And then D stands for distance stretched, right? That's how the amount of the length that the rubber band or the spring stretches, and that's squared. And then finally, you're given the number for gravity. And in this case, just to make our lives easier, we're going to use the number 10. So let's read this here. It says, a jumper with a mass of 4 kilograms is on top of a 25-meter platform. The bungee cord has a spring constant of K, there's that K again, K equals 50 newtons per meter. So what this is saying is that this bungee jumper has, at the very starting position, starts at 25 meters. Then it falls, or the person falls, so 25, 27, 5. So what we need to do is we need to fill in the missing bar charts below. We need to calculate the missing gravitational energy at each point, and then that's going to allow us to determine the missing kinetic and elastic energy at each point. Okay, you have to do these in order for this to all make sense. So on the quiz, you will have the option of getting a quiz with these bar charts either filled out or blank. If you want to retake the first quiz, either because you missed it or you aren't happy with your grade, you will get the blank one and you will fill this out on your own. Those of you who did fine and don't need to make it up, I will have a version of it filled out for you, but they're going to be different versions. So pause the video now and fill in the missing bar charts. Okay, so I actually have one that's already done. So if we zoom in here, you should see, let me just make sure I'm still recording. You should see that the total energy at the first position is completely gravitational, which matches the total energy in the system. So if we start with 8 units of energy in position 1, we need to make sure that we have 8 units of energy in every single position. So that's position 1, all gravitational. The next position, position 2, that energy has decreased. And now we have some kinetic energy because the bungee jumper is now falling. So the total energy is made up of mostly gravitational and now some kinetic. In the third position, we have another transformation of energy from gravitational to kinetic, but we also have a transfer of energy here. Some of the energy is going into the elastic because it's being stretched, so this increases the elastic energy. So this third position is where you get all 3 types of energies. And then finally in the fourth position, you still have some gravitational because the bungee jumper is still above the ground, but most of it has transformed and transferred into the bungee cord as elastic energy. The reason why it's so important to fill these out in order to calculate how much energy we have is because it allows us to figure out what kind of energy we need to calculate in the first place. So I'll give you an example here. In the first position, since we have all gravitational energy, we know that the kinetic energy is 0, and we also know that the elastic energy is 0. Okay? So all of the energy is going to be gravitational, and we can go ahead and use the equation that's given to us to find the total starting energy. So here it's mass times gravity times height. If you look at the problem, it tells us that the mass here is 4 kilograms. I'm actually going to outline that to show you what I'm talking about. This is super important information. Okay, the mass is 4 kilograms. So mass 4 times gravity 10 times the starting height, which it tells us right here is 25. So 4 times 10 is 40, times 25 is 1,000. So since we start with 1,000 joules of energy, remember joules is the unit for energy, if we start off with 1,000 at position 1, we need to make sure that every single position also adds up to 1,000. I'm going to pause here and continue the video as we go.